So how do we actually reason about what we don't know? I mean, this question is at the heart of pretty much every decision we make. And, it's not just some philosophical puzzle. It's a real, deep challenge for mathematicians and AI researchers. Today, we're going to crack open their toolbox and see what they've come up with.
I mean, really think about it for a second. Every single forecast, every medical diagnosis, every time you invest your money, it all hinges on this one question. How do you move forward in a logical way when the path ahead is, well, foggy? Turns out, math has been wrestling with this for centuries, and the answers are way more interesting than you might think.
And right here, this is the key insight. There is no one single magic formula for handling uncertainty. Not knowing comes in a bunch of different flavors, right? The randomness of a coin flip is totally different from the vagueness of a weather forecast that just says it'll be warm. Each one needs a different tool. So today, let's open up that mathematical toolkit and see what's inside.
Okay, let's start with the one you probably know best. For most of us, when we hear uncertainty, our brain immediately jumps to probability, the odds of something happening. This really is the classic cornerstone of how we've tried to tame the unknown for a long, long time.
So the classical approach is built on this really strong logical foundation. It's like it starts with a few core truths, these axioms, and builds an entire system from there. And in this world, in this system, every single type of uncertainty can, and really should, be boiled down to one single number, a probability. It's a really clean, beautifully structured way to look at the world.
And inside this framework, a rational decision just means picking the option that gets you the most bang for your buck, or what they call utility. You've got these incredible tools like Bayesian networks that help us update what we believe when new info comes in. The goal is always to find that one optimal strategy that gets us closest to the best possible outcome. It's honestly a perfect system for anything that's governed by pure chance.
But what happens when the problem isn't about randomness? What if it's about fuzzy language? Or maybe you have conflicting reports from two different sources? Well, that's when probability theory starts to struggle a bit, and we need to pull some different tools out of our kit.
And here we've got two really powerful alternatives. On one side, you have possibility theory. This is for handling vague knowledge, like that forecast for warm weather. Instead of forcing a single number, it lets you work with optimistic or pessimistic scenarios. Then, on the other side, you've got belief theory, sometimes called Dempster-Shafer theory. This one is perfect for when you have evidence you're not totally sure about, like two conflicting eyewitness reports. It lets you separate what you truly believe from what is just plausible. It's a subtle but crucial difference.
All right, this next tool in our kit, this one challenges an even bigger, more fundamental assumption, the idea that we should always be shooting for one single precise number as the answer. Because sometimes pretending you can be that precise is just, well, it's just wrong.
Think about it. Predicting a stock price down to the penny, it feels so certain, but it's also kind of deceptive, isn't it? So what if that level of precision is epistemologically wrong? That's a fancy way of saying it's a flawed picture of what we can actually know. Interval-based approaches say, hey, let's be more honest. Let's just admit what we don't know and give a range of possibilities. They treat imprecision as a feature, not a bug to be fixed.
And this is just a brilliant illustration of the whole idea. Instead of forcing an answer like, the probability is exactly 0.7, an interval approach would say, look, the real probability is somewhere between 0.6 and 0.8. That range is a much more robust and, frankly, more justified picture of our actual limited knowledge. It beautifully captures the uncertainty about our own uncertainty. And, this can get even more sophisticated. Some of these advanced frameworks can actually measure and pull apart different kinds of this higher-level uncertainty. They can break down the total fuzziness of a situation into its unique parts, which gives us a much richer picture of exactly what we don't know and, just as important, why we don't know it.
So, we've got all these tools. We have tools for randomness, for vagueness, for imprecision. Are they all just separate, floating around on their own? Not at all. The really cutting-edge work in this field is all about finding the deep connections that tie them all together.
This is where it all comes together in a really big way. These huge, unifying frameworks, like valuation-based systems, have been developed. You can think of them like a mathematical superstructure, or maybe a master blueprint that shows how all these different tools, probability, possibility, all of them are actually related. They're all members of the same big family, and each one just has a special job to do.
So why does this matter? Well, the really crucial point here is that these unifying systems let us build smarter, more flexible AI. Imagine a system built on VBS. It could use standard probability when it's looking at random data, then seamlessly switch to possibility theory when it's trying to interpret vague language, and then use interval methods when its evidence is incomplete. And it can do all of this inside one single coherent mathematical foundation. That's a game changer.
So, at the end of the day, that's really our big takeaway. Taming uncertainty isn't about finding one master key that unlocks everything. It's about being more like a skilled craftsperson, knowing exactly which specialized tool to pull from the kit to handle the specific kind of messy, imperfect information that you're facing.
And that question brings this whole thing right back home, to us. The next time you're staring down a big unknown, ask yourself, what kind of uncertainty am I really dealing with here? Is it pure randomness that I can calculate? Is it vagueness that needs to be interpreted? Or is it imprecision that I should just embrace? Knowing which tool to reach for, that's the first step toward making a truly rational choice. Thanks for joining me for this explainer.